Good evening, ladies and gentlemen. We're back once again with another amazing science tutorial video. I'm Coach Spivey, joined with my son,
Jordan Spivey.
And if you haven't already, go ahead and like and subscribe to our YouTube channel. And also check us out at our website at
www.fathersonandinterfaces.com.
So you don't miss out on even more of our amazing science content and material. But without further ado, let's go ahead and get into our video for today, which is Periodic Table Trends 101. So let's do this.
There are several trends in the periodic table. Today we will cover the following: number of valence electrons, types of ions formed by main group elements, location and properties of metal, nonmetals, and metalloids, and also phases at room temperature.
So let's go ahead and start off with number of valence electrons. And this is the amount of electrons in the outermost orbital of a neutral atom. So we'll go ahead and take a look at our periodic table. If we look in this first column right here, all of these elements only have one valence electron. So if you notice, hydrogen, lithium, sodium, and potassium all have one valence electron. Then if we move to our second column, all these elements have two valence electrons. So let's take a look at this. We have beryllium with two, magnesium, and calcium, and all three of them only have two valence electrons. And then we'll go ahead and move past our transition metals and look at our next column. And all these elements in this column have three valence electrons. So if you notice, boron, aluminum, and gallium all have 1, 2, 3 valence electrons. Then we move to our next column. All of these have 4 valence electrons. So if you notice, carbon, silicon, and germanium all have 1, 2, 3, 4 valence electrons. Then moving to our next column, all these elements have 5 valence electrons. So if you notice, nitrogen, phosphorus, and arsenic all have 1, 2, 3, 4, 5 valence electrons. Then moving to our next column, they have 6 valence electrons, and you should get the pattern by now: 1, 2, 3, 4, 5, 6 for all the elements in this column. And then our next column, we have 7 valence electrons. So if you notice, fluorine, chlorine, and bromine all have 7 valence electrons. Now if you look at the top of this column, the element right here only has 2 valence electrons, and the reason why is because we're talking about helium. And remember, on the first ring outside of the nucleus of the atom, you can only fit 2 valence electrons, so helium satisfies that. But if you notice, all the other elements in this column have 8 valence electrons, so that includes neon, argon, and krypton as well. So now let's take a look at types of ions formed by main group elements. If you notice, elements with a positive charge lose electrons in chemical bonds. So that would include elements in this column, this column, this column, and then sometimes this column as well. And the reason why it's sometimes this column, because depending upon the type of element these elements are bonding with, they may either form a positive or negative charge, which means they may either gain or lose electrons. And then if we also notice, elements with a negative charge gain electrons in chemical bonds. So that would also include the elements in this column, and the elements right here, here, and also in this column as well. And they will actually gain electrons, and that's what gives them that negative charge. Then elements in this column actually have no charge, so that's why I said 0. And the reason why is because these elements already are stable. That means they already have the total number of valence electrons they need in order to be satisfied, or to be stable to satisfy their octet rule.
Now let's look at the locations of our metals, nonmetals, and metalloids. So let's start with our metals, and since 80% of the periodic table is metals, so just so that way you can remember where all the metals are at, most of the metals are going to be on the left hand side of the periodic table, and then all of the metals at the bottom of the periodic table are going to be metals. So now let's move on to our non-metals. So hydrogen is, well, obviously going to be a non-metal because it's water basically, and so that way you can remember where all the non-metals are at, they're going to be on the right hand side of the periodic table. So that's how you remember where that is. And let's now move on to our metalloids. Our metals are basically going to be right in the center of our nonmetals and metals.
So let's go ahead and compare and contrast the properties of metals, nonmetals, and metalloids. And we'll start with states at room temperature. And metals tend to be solid at room temperature, except for mercury, which is actually a liquid at room temperature. And if you look at nonmetals, they can be solid, liquid, or gas at room temperature, just depending upon the type of nonmetal. Then if we look at metalloids, all metalloids are solid at room temperature. So let's go ahead and take a look at the appearance of all three. Metalloids have a shiny luster, while nonmetals are not shiny. And then metalloids can actually be shiny or dull. Then if we take a look at conductivity, or the element's ability to conduct electricity, metals tend to be good conductors of heat and electricity. Think about when you use a frying pan, all frying pans are made out of metal because they can take on a lot of heat without overheating. And then we use metals such as aluminum and copper to wire our houses to run electricity. If you notice, nonmetals are poor conductors of heat and electricity, and metalloids are poor conductors of heat and electricity as well. And then we move on to malleability, and that's an element's ability to be able to be bent out of shape without breaking. If you notice, metals are very malleable, and just like aluminum and copper, and we use those to wire our homes because we actually can bend those without them breaking. But if you notice, non-metals are brittle. That means they can break very easily if we try to bend them. And so are metalloids. Metalloids are brittle as well. Then we take a look at ductility, and that's an element's ability to be able to be drawn into thin wires. Well, since metals are so malleable, they are also ductile as well, and that's why we use them to wire electricity in our homes. Then non-metals, since they're brittle, they are not ductile, and if they're brittle in the first place, they're going to easily break. So we definitely won't be able to draw them into thin wires. And the same goes for a metalloid. They're not ductile as well, so we can't draw them into thin wires as well.
Now let's move on to our phases of metals, nonmetals, and metalloids at room temperature. So most metals are solid at room temperature except for mercury, which is a liquid at room temperature. So as you can see, here goes mercury. It is blue because it is a liquid, as you can see right here. Most nonmetals are gases at room temperature except for bromine, which is a liquid at room temperature. So as you can see, here goes bromine, it's blue, just like mercury, because they are both liquids. And all metalloids are solids at room temperature. So here goes silicon, which is a metalloid, or an example of a metalloid because it is in your phone. And now that we have all of our phases for our different types of metals out the way, now it's time to move on to the final part of our video. Once again, ladies and gentlemen, it is now time for our check for understanding. You may use your notes and your knowledge of the periodic table trends to answer the following questions. Once again, it is me, Jordan Spivey, signing off with my dad,
Travis Spivey. And ladies and gentlemen, also go ahead and make sure that you like and subscribe to our YouTube channel. And also check us out at our website at
www.fathersoninterfaces.com.
And ladies and gentlemen, like we always say, make sure you have a wonderful, awesome, positive day. Peace.